In this question, we're asked to find the concentration in grams per milliliter of a solution made by a student. In several other questions in this section, you're asked to do an average. When you're considering adding and subtracting and multiplying and dividing in measurements and you're asked to do an average, do not consider the number at the bottom of the average, the number of samples you have when you divide. So for example, if you have 3 masses and you want to know the average mass, when you add all the masses together, use the rules for adding, which is the number of decimal places, and report your answer with the least number of decimal places. And then you divide by 3. The 3 does not have significant figures. It is not a measurement. It is a counted number. So therefore, only use the adding rules for doing your significant figures. In this case, we do have significant figures in both the both things are measurements, the grams and the volume, so that's why I chose this as the example to go over. So in this case, first I want to figure out the mass of my sample. So I have the weight of the graduated cylinder and then the weight of the graduated cylinder after some potassium chloride has been added to it. So to find the mass of the potassium chloride, I want to take 15.805 grams minus 4.25 grams. And when you do that, the calculator will give you 11.555 grams. Now, when you're doing calculations that involve both adding and subtracting and multiplying and dividing, you don't actually want to change this number, but you want to indicate which one of your digits is for the proper one for significant figures. So in this case, it's adding and subtracting specifically. I have 3 decimal places and 2 decimal places. So my answer should have 2 decimal places. So I simply just want to put a line under that just to indicate that this is the one that's the last significant digit and this isn't. I do not actually want to round it up, however. Technically speaking, I want to use all of these digits and then round at the end. So to find the concentration in grams per milliliter, I need to take this 11.555 grams, again indicating which one has the correct number of significant figures, and I want to divide by 117.5 milliliters, the volume of the solution. And when you do this on a calculator, you get a very, very large number, 0.0983404255532. And when I say large number, I mean lots of digits, and this is just as many as my calculator would give. I'm guessing it keeps going. And we need to report this with the correct number of significant figures. So in this case, even though we use this number, which has 5 total significant figures, only 4 of them were valid because of the subtraction rule up here, 2 decimal places, 2 decimal places. You should still use the whole number, but indicate which one is a valid number of significant figures. This gives us 1, 2, 3, 4 sig figs, because remember for dividing, it's the total number of significant figures. On the bottom, our measurement has 1, 2, 3, 4 significant figures. So they're both 4, which means our answer should be 4. This leading 0 is not significant because it's only after a decimal place, it's not after a sig fig. So we count over 1, 2, 3, 4. This is our 4th significant figure, and our answer is 0.09834 grams per milliliter.